Hi, this is Jeff Carpenter. Let's talk about how to secure DataStax Enterprise in your environment. First, a couple of disclaimers. We all know that security is a big topic with a lot of facets. In this section, we're going to focus on the basics, like setting up authentication and authorization using DSE's built-in security. For a more full treatment of security, we offer another course, DS410. That covers everything you need and best practices in more detail. Let's start with configuring authentication and authorization. Just to define our terms, when we say authentication, we're talking about controlling who can access our cluster and how we know who they are. When we talk about authorization, we're referring to what actions those users are allowed to perform. So let's talk about authentication. When you install DSE out of the box, authentication is disabled. You enable authentication via configuration files, as we'll discuss in a minute. When authentication is enabled, clients like CQLSH, DSE tool, or your application must provide credentials, such as a username and password, to DSE. Cassandra's extensible architecture allows us to provide pluggable authentication and authorization mechanisms. DSE implements authentication via the DSE Authenticator. The DSE Authenticator provides 3 different authentication schemes to meet the needs of various environments. It can plug into your existing Kerberos or LDAP authentication, or there's a built-in authentication using the internal scheme. This built-in or internal authenticator is the one that we'll focus on in this course. We configure the DSE Authenticator using options in the dsc.yaml file, as shown to the right. Here's how to configure authentication on each node in your cluster. First, you'll edit the DSE YAML file to enable authentication using the desired scheme. Next, restart the node to enable authentication. Then, you can log into the node using the default role with username Cassandra and password Cassandra. This default Cassandra role is an administrative role known as a super user that has all permissions. Now, this isn't a great thing to have available, especially in a production cluster. You will want to change this right away. To do this, use the alter user command to set a new password for the Cassandra user. The internal authenticator uses Cassandra tables in the system auth key space to share user credentials across the cluster. For this reason, it's important that the replication strategy for this key space be configured appropriately for your deployment. An example is shown on the slide. You'll want multiple replicas of these credentials in each data center in your cluster, so that DSE will be able to authenticate users even if you have nodes go down or lose connectivity between data centers. Let's take a quick peek under the hood to see how this works. DSE stores user and role information in a table called roles in the system auth key space. Each row in the roles table stores the name of the role, the roles that are granted to that role, whether the role represents an individual or a true role shared by multiple users, a flag indicating whether the role is a super user role, and the password. The passwords are stored in an encrypted form using a salted hash. Let's see what this looks like in practice with a few CQLSH commands. First, we might want to create a role called Fred. Give Fred a password and allow him to log in. There's some other commands that we might want to use to list the available roles, or even to delete a role to remove that user or role from the system. Let's wrap up our discussion of authentication with a couple of best practices. At a minimum, you should change the default password for the Cassandra user. Another approach you can take is to create another super user account, log in as that super user, and then delete the default administrator account. Finally, don't forget to set the replication strategy for the system auth key space to something that is appropriate for your cluster topology. Next, let's talk about authorization. To give permission to users and roles, we use the grant operation in CQL. The syntax works like this. The grant command, followed by the operation we're allowing, followed by the name of the key space or table we're granting the operation on, followed by the user or role name that we are granting this permission to. Here's a list of the various permissions that we can grant and which operations are implied by each one. The permissions that we can grant allow us to do things like create, alter, modify, or delete tables. We can also grant permissions that allow us to be able to select, insert, or update data. Let's look at some other examples. These commands show us the creation of a role called DB accessors, which is a true role because we have not set login to true. We can grant some permissions to the DB accessors role, and then later we can grant this DB accessors role to users such as Fred. We can remove permissions from a user or role by using the revoke command. Let's take a minute and go do an exercise on authentication and authorization. You could try it out for yourself. Don't worry, I'll be here when you get back. Now, let's talk a little bit about encryption using Secure Sockets Layer, or SSL. We may want DSE to encrypt data as it is moving around our cluster, between clients and nodes, from node to node, or even as it's stored on disk. We're just going to look at some of the basics here as we cover encryption in more detail in DS210. Let's look at how SSL works. First, the client requests the certificate. Second, the server sends the certificate back. Third, the client verifies the certificate. Now, normally, the client verifies using a certificate authority, but in this case, it's a self-signed certificate, so the client looks in its trust store. This is why the certificate of every node must be stored in the trust store of all the other nodes. Fourth, the client generates a symmetric key, encrypts the key using the server's public key from the certificate, and sends the symmetric key to the server. Finally, in step 5, both machines share the symmetric key so they can use it to communicate securely. The purpose of this process is to create two artifacts that Cassandra needs: a key store containing a signed key pair and a trust store containing a root certificate authority, or CA. Cassandra nodes present the node's signed certificate from the key store to prove they are part of the cluster, and nodes will use the trust store to authenticate the presented signed certificates from other nodes. First, create a root certificate authority. The root authority is at the head of the trust chain. We will sign all nodes' certs with this root authority, and we will authorize all incoming connections using the root certificate. Second, on the same machine where you created the CA, for each node create a key store with a key pair. Once signed, the node will present the certificate to other nodes for authentication, and will use this key to encrypt communications to other nodes. Third, we need to get the node's certificate signed. So, still on the same machine that has the certificate authority, create a signing request for the node's certificates. Fourth, sign all the node's certificates using the root certificate authority key, still on the machine with the CA. Fifth, for each node, import the root CA into the key store so that the node's signed certificates can be imported into each node's key store. Sixth, now import each node's signed certificate into its key store. As mentioned, we can now use this signed certificate for authenticating our communications. Seventh, and finally, create a trust store containing the root CA cert. 8. Copy the trust store and each node's key store to the node's machine. Notice that we did all the previous work on a single machine, so we would not have to transfer the CA's private key to any other machine. Here are some best practices for configuring encryption via SSL. First, you'll want to make sure to take good care of your private keys and your root store certificate authority keys, and store them in a secure location. Next, you'll want to secure your network so that nodes can only interact with each other via the listen port. Finally, you'll want to use encryption and authentication in combination. Make sure that each node is configured to require client authentication so that only clients you approve can get access to encrypted communications.